Welcome back. Electric cars like the Tesla are becoming more and more popular. The Tesla is run by a lithium-ion battery pack found under the bottom of the car. Lithium-ion batteries are found in all sorts of devices, such as pacemakers, laptops, and cell phones. Here's a lithium-ion. Our job this lesson is to figure out the names and formulas of monatomic ions like that one. How do you feel about that? Let's start by reviewing a few things. What monatomic and polyatomic ions have in common is they both have a charge. They differ in that monatomic ions have only one atom and polyatomic ions have more than one atom. And here you see some examples of each. Recall that for both monatomic and polyatomic, the positive ions are called cations and the negative ions anions. Having said all that, the focus of this lesson is learning the names and formulas of the monatomic ions. But first, one final review concept. Recall the main group elements have certain group designations. We call this group 1A, this 2A, 3A, and so on, up to 8A. Remember these labels and have a periodic table handy as we proceed through this lesson. First, we'll cover charges, then names. For charges, our first category is type 1 cations. These are cations that have only one possible charge. The lithium ion is an example of this because the only charge lithium ever forms is +1. The way you know the charge of most type 1 cations is by identifying what group it's in. Recall we've done this in a prior lesson. Group 1A elements, like lithium, form a +1 charge. Group 2A a +2, Group 3A a +3. However, here we are emphasizing aluminum in particular. Other metals in group 3A form +3 charges, but aluminum is the only one that forms only a +3. Finally, for the type 1 category, also learn that silver forms a +1 and zinc a +2. These you just have to memorize. There's no simple way of looking at the periodic table to determine what their charge would be. On now to type 2 cations. These are monatomic cations with more than one possible charge. Those that are type 2 are generally the transition metals and the post-transition metals. There are exceptions, such as the silver, zinc, and aluminum we've already seen. Having said that, there are only two type 2 elements I'd like you to memorize. The first is copper, and you should know it can be a +1 or a +2. The next is iron, which can be +2 or +3. Okay, so far we've been talking about the charges of monatomic cations, both type 1 and type 2. Now it's time to move on to monatomic anions. Luckily, there's only one type here, and the way we know the charge is again based upon what group it's in. Let's start with nonmetals in group 5A. Their charge is -3. And we say nonmetal because we're only talking about the nonmetals in 5A. Group 6A nonmetals form -2 charges, and group 7A a -1. Finally, although hydrogen frequently will form a +1 charge, when it forms a monatomic anion, it's -1. We now turn from charges to the names of monatomic ions. Let's start with type 1, and what you need to know here is they retain the name of the element. It's the easiest thing you'll have all year. When sodium is neutral, it's called sodium. When it forms a +1, it's still called sodium. Strontium is still called strontium when it becomes positive. Same for aluminum. Now on to type 2 cations. Since these cations have multiple charges, we need naming rules that indicate which charge we're dealing with. There are two ways of doing this. The first we'll call the systematic system, and for this, Roman numerals are used to indicate the charge. For example, we've already seen that copper can be +1 or +2. Well, the +1 ion is called copper 1. This Roman numeral tells you the charge of this one is +1. The other is called copper 2, representing the ion with a +2 charge. Here are the corresponding names for the two ions of iron. Here are some others. To be clear, you don't have to memorize nickel can be +2 or +3. But if you were to see the name nickel 3, you should be able to write this formula. Let's do some quick practice. Write the formula for the two ions you see here. Remember, formula means write the symbol and the charge. Stop the video now. All right, there you have the answers. Let me know if you have any questions. Okay, please try this next one on your own. Stop the video now. We would never say or write barium-2 with the Roman numeral included because barium can only be a +2. There's no other possibility. Elements in group 1A are always +1, group 2A like barium always +2, and aluminum group 3A always +3. Roman numerals are only necessary when the element can have more than one charge. So, we're dealing with the names of type 2 cations. The systematic system involves using Roman numerals. The second system is called the common system. And this works by using Latin root names and combining that with special endings. For example, the Latin name for copper is cuprum, so copper 1 adopts an OUS ending and becomes cuprous, and copper 2 takes an IC ending to become cupric. The ions of iron exhibit a similar pattern to give ferrous and ferric. Let's make something clear here. A particular ending does not indicate a particular charge. For example, notice the OUS ending in cuprous refers to a +1 charge, but the OUS ending in ferrous relates to a +2 charge. What is consistent is that for a particular element, the lower charge will have the OUS ending and the higher charge the IC ending. That applies to other elements as well, like what you see here. Notice how the lower charge for tin, a +2, ends in OUS, and the higher charge +4 ends in IC. To be clear, the only two you would be expected to memorize the charges and common names of are copper and iron. Let's wrap this names of cations section by having you answer all the questions you see here. Try it without consulting your notes. Stop the video now. Fe+2 can be iron 2 or ferrous. For the next one, you need to recall cupric is copper and is Cu. And then you need to remember the IC ending for copper means +2, because copper can be +1 or +2, and the higher charge gets the IC ending. Gold is Au, and the Roman numeral 1 tells us the charge is +1. Finally, potassium is K, and you can then refer to a periodic table and see it's in group 1A, and therefore has a +1 charge. Last thing, naming monatomic anions. Unlike cations, in this case you do change the ending. Monatomic anions end in IDE. So chlorine here, when it's neutral, becomes chloride here when it's negative. Oxygen becomes oxide, nitrogen becomes nitride, and so on. Remember, except for the common names, cations keep their usual name, but anions end in IDE. Let's wrap it up by practicing some. For these problems, we need to give both the formula and name of the common ion of these elements. Let's do the first one together. Calcium we need to remember is Ca. Then we look at the periodic table and see it's in group 2A and therefore has a +2 charge. Then we recall that type 1 monatomic cations retain the name of the element. So this ion is still just called calcium. Finish the last three on your own. Stop the video now. Here are all the answers. Please check them over and let me know if you have any questions. Well, that's it for names and formulas of monatomic ions. See you next time when we tackle polyatomic ions.